bit at school, but it's kind of like I still have some questions about it. So, first problem is 10x squared.
Hold on. This thing is sketchy at best. Alright, now I can write. 10x squared.
Yep, 10x squared. Plus 20x minus 71 equals 9.
Okay. So, first of all, we can view this as a regular quadratic. And we could turn it into this. Let's see, if I subtract 9 from both sides, I got that. Okay. And that's usually what you want to do as your first step. You should want to get everything on one side of the equation and you want to get 0 on the other. Which is all I've done. Now what?
Don't you like cut the, or move the coefficient to the other side?
Consider greatest common factor as your first step. Always.
Okay.
Is there a greatest common factor that I can factor out of the first term? On the left.
Yeah, 10.
Okay. That does a lot because it makes the inside real easy to work with. In other words, that is an elementary quadratic. We could factor it if we want. Now, it factors rather easily. It factors into x plus 4 times x minus 2. However, what do the instructions say? Solve by what?
Using or completing the square.
All right. So we're going to complete the square. Now, let me think on how they want you to do this. There's a number of choices. Well, I hate this problem for a completing the square problem. It's terrible. First of all, it shouldn't be something that can be factored. What do I do for my first step here? If I'm going to complete the square. If I'm going to factor it, I'm going to move the 9 to the left. But if I'm going to complete the square, I'm going to move the 71 to the right.
Right.
So what does that give you?
80.
Okay. Now, I can still divide everything by 10, right? All right. Let's talk about completing the square.
Okay.
You can complete the square whenever you have an x squared term and an x term. And the way you complete the square is by taking half of the coefficient of the x term and squaring it, and then adding it to both sides. Well, what's half of the coefficient of the x term?
1.
Square that.
1.
So I'm going to add plus 1, which means I have to do what to the other side?
Add 1.
Now, The whole point of completing the square is that you can write it as a linear term. What is this term going to be? X plus what squared?
X plus 1.
Exactly. Whatever you got when you took half of that coefficient, that's what goes there. So this whole thing can be written like this, which is wonderful because there's a lot of formats that are like vertex format.
Mm-hmm.
And even if it's not vertex format, I can solve it. What's the next step? If the question is solve for x by completing the square, well, we've completed the square. Now how do we solve for x? From this step right there.
Square root.
Okay. So we get x plus 1 equals what?
X plus 1 equals 3.
Whenever you solve an equation by taking the square root of both sides, always start your answer with the words plus or minus. Well, what is it? Plus or minus 3. Notice that minus 3 times minus 3 is plus 9. Plus 3 times plus 3 is plus 9. So there is no doubt about that solution. What does that make x?
X what?
Yeah, you still have to solve for x. That was the original problem. Solve for x.
Well, it'd be x equals plus minus, or negative 1 plus minus 3, or...
Okay, x equals plus or minus 3 minus 1, correct? What two answers does that give you?
It would be negative 4 and positive 2.
Correct. Those are your two answers. And you would expect two answers with a quadratic. You always have two answers. It's very rare that you only have one answer. So when you have a quadratic, you're going to have two answers. When you have a linear, you're going to have one answer. When you have a cubic, you're going to have three answers. Okay? Now, it turns out that I could have factored that and come up with these two solutions just as easily. In fact, a lot more easily. I wouldn't have had to complete the square. I would have just had to factor it. But that's okay. Completing the square is definitely a process in Algebra 2 that you need to learn. There are a lot of places where you have to complete the square. And it's real easy. It's not hard. You take half of that, you square it. And then you balance it on the other side. That's it. And then once you've completed the square, you can always write this term as a linear term squared. That's why you complete the square, is so that you can write it as a linear term, x plus 1. It's a linear term squared.
Right.
And I can solve the problem by taking the square root of both sides. It's real easy. What else you got?
Here's one. 2x squared plus 16x minus 70 equals a negative 4.
When you look at this problem, what's the first thing you think of? And this is important. It's important that this be the first thing you think of.
Like, what do you mean? Like, what do I do, or?
Well, I got an even number there, an even number there, an even number there, an even number there. What's the first thing I'm going to do?
Take a greatest common factor?
Divide everything by 2.
Oh.
As long as I have even numbers everywhere, I can divide by 2. Even numbers are always divisible by 2.
Mm-hmm.
So if I divide both sides by 2, I get this. Correct?
Right.
Now, they want you to complete the square. So, if I didn't have to complete the square, I would try to factor it. But they say complete the square.
Mm-hmm.
There's a couple of ways you can do this. I prefer putting everything on one side, 0 on the other. So what does that give me?
It would be 33?
Minus 33.
Negative 33.
Okay, now I have a natural looking quadratic. Got everything on one side, 0 on the other. That's the most natural quadratic you're going to see. Now, it turns out I can actually factor that. I'm looking for factors of 33 that subtract to 8. Well, that's 11 and 3. So I could solve it much easier than completing the square. But since the instructions say complete the square, I'm going to do this. Notice I did not change anything.
Mm-hmm.
All I did was rearrange it. Now, what is the process for completing the square inside the parentheses?
Cut 8 in half and then square it.
Okay? And it's always being added, never being subtracted. What is that?
It'd be 16.
Now, I just added 16 to the left side of that equation. What do I have to do to balance it?
Add it to the other side.
Or subtract it from the same side.
Yeah.
Notice that I added 16, I subtracted 16 from the same side. Now, the advantage of that is now that can be represented by a linear term. X plus what?
X plus 4
Squared.
squared.
If you square x plus 4, you will get the quadratic above it. Always. 100% of the time. That's the whole reason completing the square is done. Is so that you can represent that quadratic as a linear term squared. What's the total minuses we have?
49.
You need room to write. We're starting with the bottom row. How do I solve the bottom row? Remember, the request is to solve for x.
Mm-hmm. So
What's the next step?
Wouldn't you plus 49 now?
Yeah, absolutely. What's the next step?
Then you would
Now we're just talking algebra. How do you solve this algebraic equation?
Square root both sides.
Okay, what do you get?
You'd get x plus 4 equals 7. Or plus minus 7.
Ah, thank you. 95% of my students miss the plus minus.
Mm-hmm. Then you would minus 4.
The rule is, if you're ever solving an equation by taking the square root of both sides, always begin your answer with the words plus or minus. Always. 100% of the time. So what's x equal to? If x plus 4 equals plus or minus 7,
it would be
do that one first.
Okay, so it'd be 3, and it would also be negative 3, or negative, sorry, negative 11.
Both of those answers are correct. That is your final answer. And notice that I needed that plus minus. If I did not put that plus minus in there, I would have only gotten this answer. I would have completely missed this one. So that plus minus is extremely important. If you're taking a test and you leave it off, you're going to lose points. No question about it. Okay?
Okay.
All right. What else you got? About 10 minutes. 12 minutes?
X squared minus 16x plus 50 equals 2.
Are the instructions to use completing the square to solve this?
Yes.
Because if they're not, there is usually an easier way to solve this. But if the instructions are to complete the square, then I want to get those two terms on one side. Okay? Now I want to complete the square. Well, how do I complete the square there?
Square root both sides.
No, it's not square.
Sorry.
Both side is not square. Completing the square is a process. You take half of the coefficient of the x term and square it. What is that? What's half of the coefficient of the x term?
8, and then squared is 64.
Okay, and it's always added. Because even if it's negative 8, like this case, when I square it, it becomes positive. Okay, now how do I balance it? I can't just arbitrarily add 64 to the left side of the equation.
You gotta add 64 to the other side.
Yeah. Now, because I completed the square, that can be written as a linear term squared. What is it?
It'd be 8.
Minus 8.
Yeah, negative 8.
In other words, whatever you got when you took half of that. Okay. Well, the right side is 16. Now what?
Square root both sides.
Okay, so you get x minus 8 on the left. What do you get on the right?
4.
Nope.
What?
Whenever you are solving an equation,
Plus minus 4.
taking the square root of both sides, always begin your answer with the words plus or minus.
Okay.
I don't know how else to say it. It's one of the hardest things I teach in terms of getting the students to know it. They just don't. 90% of my students leave off the plus minus. and yet it's half the answer. You can't leave it off. If you leave it off, you're missing an entire solution. So what's the solution?
It would be x is equal to 12 and x is equal to 4.
Perfect. Both of those are the solution. Had you not used the plus or minus sign, you would have only gotten that. You would have missed the 4. So it's really, really important to use that plus or minus. And you only do it when you're taking the square root of both sides. In other words, what's this equal to?
Plus minus 4.
No.
What?
That's equal to 4. When I use the radical sign, it designates the plus side only. If I want the minus 4 answer, I'm going to do that. So it's not when you have a radical sign that you use the plus or minus. It's when you have an equation that you are taking the square root of both sides. In other words, if I say that, there's an equation. You're going to solve it by taking the square root of both sides. What are you going to begin your answer with?
Plus minus.
That's the rules.
Okay.
So a radical sign always implies the positive result.
Okay.
But when you're solving an equation, it's both of them, the plus and the minus. It's a little confusing, I acknowledge that, but that's the way it works. What else you got? We got a little less than 10 minutes.
I don't have any more.
Okay, let me give you one.
Okay.
Because this gets to the root of a different problem. Solve this by completing the square.
Okay, so I would first divide everything, or divide 2x and 16x by 2.
Yeah, it's not obvious, but you cannot complete the square until that x squared term has a 1 in front of it. That's the rules. You just can't do it. Now, the key thing is when I go from that row to that row that I do not change anything. Have I changed anything?
No.
No, it's exactly the same thing. I've just algebraically manipulated it. Now, because that term has a 1 in front of it, I can proceed to complete the square. How do I complete the square?
Half of 16, so 8, and then square that, 64.
What's half of 8? It's not half of 16, it's half of 8.
Oh, yeah, sorry, half of 8. So 4, and then it's 16.
Okay. Now, when I wrote that 16 in there, how much did I add to the left side of the equation?
16.
Did I really? It's being multiplied by 2.
8. No, sorry, 32.
Okay, so I got to add 32 to the other side.
Right.
And this is harder because I factored something out, but when I add that third term, I got to multiply it by what I factored out because I really have added 32 to the left side. Now I get 2 times, how can I write what's inside the parentheses? X what? Something squared.
X, plus 4.
Yeah, there's the linear term squared. That you're always going to be able to do that. That's the whole point of completing the square. Now what?
Then you would square root both sides.
Not quite. In order to square root both sides, you got to isolate that.
So you divide everything by 2? Wait.
Yep. Gets rid of that. Now I've isolated that, what can I do?
Square root both sides.
Yeah. So what do I get when I square root both sides?
You get x plus 4 and plus minus square root of 43.
43 halves. Right?
Right.
Okay. So what's x equal to? Just leave it as 43 halves for the moment.
It'd be plus minus 43 halves minus 4.
There you go. Now, it's not a big step to figure out both solutions from there.
Mm-hmm.
What are they?
So one of them would
You have to be able to add a whole number to a fraction.
One would be 17 and a half.
Well, let's just leave it all in halves. So the first one's going to be 43 halves minus 4. How many halves is 4?
8.
What's that equal to?
That'd be equal to 35.
That's one solution. The next solution is minus 43 halves minus 4.
Mm-hmm.
Again, 4 is how many halves?
4. Or 8, sorry.
That's all right. Now do that math. You have a common denominator.
It would be negative 51 halves.
There's your two solutions.
Mm-hmm.
Now I made this problem up off the top of my head, so we came out with odd numbers. But that's okay. You're going to come up with odd numbers a lot of times. They're not always going to be integers. But this illustrated the problem perfectly in terms of completing the square. And more so, it told you how to do it when you have a number in front of the x squared term. Let's even go a little bit harder, because it doesn't matter whether it's factorable or not.
Mm-hmm.
I'll make it a little easier. Let's put that 11 on the other side. Complete the square on this one.
Okay, so you divide everything by 3?
Yes, you have to factor out whatever that number is. Even if it does not divide evenly into 10, you still have to do it. You cannot complete the square until the coefficient of that x squared term is 1.
Mm-hmm.
It's the second term.
Second term would be 5.
Well, you're dividing everything by 3. I'm factoring out a 3. When I divide that by 3, what do I get?
10 over 3.
Yeah. It's not a whole number, but it's still the right answer. Now, the most important thing you can do is check to make sure you have not changed anything. Have I changed anything?
No.
No, it's exactly the same as row 1. It's just I've algebraically manipulated it so that the x squared term has a 1 in front of it. Now, how do I complete the square?
You take half of 10 over 3.
What is half of 10 over 3?
Like, I don't know, like,
10 over 6.
okay.
In other words, here's what I'm doing. 1/2 times 10 over 3. That's 10 over 6.
Okay.
Which is 5/3. Now square that.
5/3 squared, that would be 25 over 6.
Over 9.
Over 9,
Got to
sorry.
square top and bottom.
Yeah.
Now I got to balance. I can't just arbitrarily add 25/9.
Mm-hmm.
What do I add to the other side to account for that 25/9 that I just added to the left side of the equation?
You have to add to the right.
How much?
Well,
25/9?
no, it's 3 times 25
That's
ninths.
75/9. Now everything's the same. Now, how do I rewrite the part that's in parentheses as a linear term squared?
X plus 10/6.
Or 5/3.
Or 5/3.
Okay? Equals, for the moment I'll just write it like this. Okay?
Mm-hmm.
With me?
Yep.
What's the next step gonna be?
It's gonna be square root, or no, it's gonna divide by 3.
Exactly. You got to get rid of that 3 before you can take the square root of both sides. That 3 is not being squared. Only the x plus 5/3 is being squared. So, I made this problem up in my head, so it becomes a little tough. So it's 99/9 plus 75/9 equals 174/9. Now I got to divide that by 3, both sides. So that's what I get, is x plus 5/3 squared equals 174 divided by 27.
Mm-hmm.
Now I can solve for x by taking the square root of both sides. In other words, once you get it to this step, you can always solve it by taking the square root of both sides, which means your answer is going to start with the words plus or minus, and then you're going to be dealing with a lot of fractions that aren't any fun. And the reason you are dealing with those fractions because I made this problem up on the top of my head. So I didn't make it up so that you're going to have nice, even integer answers. Doesn't matter. This actually illustrated the problem better. In other words, because you have to factor out a 3, doesn't matter whether 10 is divisible by 3 or not. You still have to factor out a 3. You get this odd fraction, but you can still take half of that and square it, which is 25/9. Add 25/9 times the 3 to the other side, and you're halfway towards the solution. The thing to remember is that when you complete the square, the whole reason you do it is so that you can write that thing as a linear term squared. Notice x plus 5/3 is a linear term. Linear meaning the x is only to the 1 power. So it's x plus some number squared. Now that's easy to solve by taking the square root of both sides. That's the basic premise of completing the square, is that so you can write the x squared and the x value as a linear term squared. This was definitely one of the hardest ones. You won't probably see that on a test. I could have made it a little easier by making that a 9, but I didn't want to. I wanted to make it as hard as possible because the most important thing to realize is that that middle coefficient does not have to be divisible by 3.
Mm-hmm.
You still have to factor out the 3. Doesn't matter
Mm-hmm.
when it makes the middle term coefficient.
Mm-hmm.
Okay? Blake, any other questions for tonight?
Nope.
All right. I will let you go. You have a good evening. I'll talk to you next time.
Thank you, you too.